For years now, the internet has been arguing about AI, whether it's real, whether it matters, whether it's going to change anything. While that argument was happening on the internet, something great happened. A cancer treatment designed around one patient's exact mutations. $442 billion in fraud was fought in a single year. A weather forecast more accurate than anything humans built in 70 years. AI isn't arriving, it's already here. Here's what that actually looks like. Imagine you are tapping your card to pay for a coffee. In the next millisecond, before you've even lifted your card, an AI has analyzed over 400 risk factors about that transaction and made a decision. Fraud or not? That system isn't guessing. It can't guess. It runs one specific job trained on billions of transactions with no room for interpretation. Now compare that to someone asking a chatbot for a restaurant recommendation, and it confidently sends them to a place that closed 2 years ago. Both of those are called AI, but they are not the same thing. And the skepticism that's rightly aimed at the chatbot doesn't apply to the one used for the infrastructure. One is a toy, the other is the backbone of the global economy. The companies building on it aren't talking about potential anymore. The proof is already in. Here's what it shows. The global financial system processes billions of transactions every single day, and hidden inside every one of them is a threat. Someone trying to use a card that isn't theirs, breach an account, move money they shouldn't have. For decades, catching that threat was slow, manual, and reactive. By the time fraud was detected, the damage was already done. That changed when AI became the first line. According to the 2026 Interpol Financial Fraud Assessment, over $442 billion was siphoned from the global economy in 2025 alone. The industry's response? A shift to what they're calling the zero latency principle. AI systems that don't just detect fraud in motion, but analyze behavioral intent before a single cent even leaves an account. Major institutions like Citigroup and Bank of America have moved to Agentic AI, autonomous systems that execute entire security workflows without a human ever touching the keyboard. Nearly 98% of all fraud triage is now handled by AI alone. But the most remarkable layer is invisible. Called behavioral biometrics, it measures the rhythm of your typing, the exact angle you hold your phone, even microsaccades, tiny involuntary eye movements that no deepfake can replicate. The system builds a unique behavioral fingerprint for every user. And when a genuine threat is identified, the system doesn't block it immediately. It uses a tactic called shadowing. The transaction appears successful to the attacker while the funds are quietly diverted into a secure holding account. The attacker thinks they won, but they did not. That's what AI does to the financial world. What it's doing to biology is a different order of magnitude entirely. 6 years. That's how long it typically takes to move a drug from discovery to the first human trial. It's a process of constant failure because biology is the most complex code we've ever tried to read. But we've stopped treating biology as a mystery and started treating it as a data problem. AI-native biotech firms are now completing that same 6-year cycle in under 18 months. And their phase 1 safety trial success rate is now hovering between 80 and 90%, nearly double the industry average. In early 2026, Isomorphic Labs launched IsoDead, a model that more than doubles the accuracy of previous systems on the hardest molecular targets. Combined with Alpha GNoME, which can now decode the 98% of the human genome previously labeled as dark matter, the time to predict a genetic mutation's impact has dropped to under 1 second. The real-world proof arrived in January 2026 at UC San Diego. In a clinical trial of 210 patients with advanced cancers, AI analyzed every individual tumor profile. The results were startling. 95% of those patients had entirely unique DNA signatures. A standard drug would have failed them. Instead, the AI designed 157 individual treatment regimens, including 103 drug combinations that had never been tested before. The patients whose treatment matched their exact mutations survived significantly longer. This is the precision of a single DNA strand. but the same underlying architecture is now being applied to the massive chaotic physics of our entire atmosphere. For 70 years, weather forecasting was a battle of raw compute. We fed atmospheric data into supercomputers, ran trillions of physics-based equations, and waited hours for the output. Even then, the result was only reliably accurate about 5 days out. The gold standard for this has always been the ECMWF in Europe. Governments, airlines, and logistics giants all route their multi-billion-dollar operations around its data. But in late 2023, the paradigm shifted. DeepMind published GraphCast, an AI model that produces a 10-day global forecast in under 1 minute on a single machine. It didn't just match the experts, it outperformed the industry's best on 90% of verification targets. During a live deployment, it predicted Hurricane Lee's landfall in Nova Scotia 9 days before it happened, 3 days earlier than traditional physics-based solvers. The real validation came in February 2025. The ECMWF officially brought its AI forecasting system into operations. They didn't just add a feature, they began a fundamental transition away from legacy numerical weather prediction. The new system is not only faster, it uses 1,000 times less energy to generate the same result. 70 years of incremental physics, then 3 models in 3 years outperformed all of it. The institutions that built the original systems didn't just notice the shift, they surrendered the gold standard to it. But AI isn't just being used to predict the natural world we already have. It is now being used to literally invent the materials of the future. Before AI, discovering a new material, a more efficient battery electrolyte, a better superconductor, was a process of trial and error that could take decades. In the entire history of humanity, we had discovered about 48,000 stable crystals. Then came GNoME. Google DeepMind's graph networks for materials exploration predicted the stability of 2.2 million new crystals. To put that in perspective, that is roughly 800 years worth of human knowledge produced in a single run. But this isn't just theoretical. Researchers at the Lawrence Berkeley National Laboratory used an autonomous system called the A-Lab to test whether these AI designs actually worked. It successfully created 41 of the new materials suggested by the AI, with a 70% success rate for AI design structures. We can now move from AI prediction to physical matter without a human ever touching a beaker. We are no longer waiting for the next Bronze Age or Silicon Age to happen by accident. We are now engineering those ages on demand. But as we gain the power to build the world at the molecular level, we face a new problem. The speed of the digital world has moved beyond human control. And while all of that is being rebuilt, someone is trying to break it. Back to that number from the start of the video. 27 seconds. According to the 2026 CrowdStrike Global Threat Report, that is the fastest recorded breakout time on record. The time it takes for an attacker to move from a single compromised laptop to full network takeover. While the average breakout time fell to 29 minutes in 2025, the extreme cases are now moving at a speed that renders human intervention impossible. Even a dedicated security analyst watching a live monitor cannot react, reason, and remediate a threat in under half a minute. At these speeds, AI is no longer a luxury. It is the only viable first line of defense. Modern security teams are now deploying Agentic AI to fight at machine speed. CrowdStrike's Charlotte AI triages and assesses security alerts with 98% accuracy, resolving them before they ever reach a human desk. But the real shift in 2026 is the move toward Level 5 autonomous defense. A company called Sevi launched an autonomous defense and remediation platform that uses cyber warrior agents to hunt and remediate threats at the network edge with no human in the loop, allowing security engineers to focus on high-level strategy rather than manual alert triage. The fight has also moved to the human layer. As deepfakes become a corporate liability, detection tools are shifting from analyzing pixels to analyzing biological reality. Resemble AI now detects synthetic audio with 98% precision across 30 languages. Meanwhile, Intel's Fake Catcher uses a technique called remote photoplethysmography to read blood flow patterns in human facial tissue. It looks for the subtle pulse in the skin that a deepfake simply cannot replicate. For the first time in the history of the digital arms race, the defenders finally have the tools to operate at the same speed as the attackers. Look, the results across these 5 sectors point to a singular conclusion. AI has moved from a speculative tool to foundational infrastructure. The transition is now visible across the entire stack. We are seeing financial systems operating at zero latency and biotechnology producing 103 patient-specific drug pairings. Weather models have been optimized to run with 1,000 times less energy, while 800 years of material science has been compressed into a single weekend. And in the digital world, response times have collapsed to sub 30 seconds as autonomous agents take over the first line of defense. This isn't a roadmap. These are the numbers that held up. The organizations treating AI as a core abstraction layer, not just a marketing checkbox, are setting a pace that is becoming impossible to catch. Everyone else is deciding right now whether to close that gap or watch it widen forever. Which of these breakthroughs do you think will have the biggest impact on your field? Drop your take in the comments. I am curious to see which one surprises the tech community most. If this gave you something to think about, hit subscribe. This is Sunny on AI, bringing you the real story unfiltered. Until next time, take care.